It is time to solve some systems of equations by graphing. Goodbye, Theodore. You heard a car alarm. Anyway, so remember what a graph means. When we look at a graph or talk about the graph of a function, it's just all the points that make that equation or function true. So if we have two functions, the solution of the system is the point that makes both equations true. So it's got to be both on both of the lines, right? If I have one line, well, that line is all the points where one equation's true. If I have another line, that's all the points that make that equation's true. So when are both equations true, that'll be the solution of the system. At this point, x comma y. That's really what we're doing right here. So let's do an example. Solve the following system by graphing by hand and check your answer. So let's graph these equations by hand. Couple ways of graphing lines. You could plot 2 points, or you could put it in the form y equals b plus mx. Up to you. If we put things in the equation y equals b plus mx, we have to subtract 2x from both sides of this first one. If we do that, we're going to get y is equal to negative 8 minus 2. Gosh, I'm going to change this problem. Let's change this to a positive 8. I'm just adjusting the problem, not doing any math, just editing the notes. And then we get this equation, y equals 8 minus 2x. So if we do that, the y-intercept is positive 8. 1, 2, 3, 4, 5, 6, 7. Oh, that's still way up here. And the slope is negative 2. Negative 2 can be written as negative 2 over 1. That's the same thing. It means we go down 2 and right 1. Down 2 and right 1. Down 2 and right 1. And this is what that equation looks like. All right, and this is the line, 2x plus y equals positive 8. And we can do that for the other one as well. Let's subtract x from both sides. We're going to get y is negative 1 minus x. And then let's multiply both sides by negative 1. Y equals positive 1 plus x. The y-intercept is positive 1. I'm going to call this m1. That was our first slope. So our second slope is positive 1, and we could write that as positive 1 over 1. Right? There's a 1 right here. We don't write 1x. We just write x. But when you see an x, it's always 1 times x. So that means we go up 1 and right 1, up 1 and right 1. And my program is freezing again. Thank you, Microsoft Edge. Could really use a different program. Anyway, maybe it'll catch up soon. In the meantime, while my program is freezing, oh, it's back. You could keep adding more points. All right, so then we go and we connect the dots and we look for our solution. You can find our solution is where they overlap. Oh, wait, hold on. I want to label this graph too, right? This is the graph x minus y equals negative 1. You could find the solution. It's where they overlap, which is right about... Oh. What point is that? Well, it looks like it's close to maybe an x value of 2.225, maybe? Maybe a y value of 3.5? I don't know. That's the problem with graphing, okay? So solving systems by graphing can be nice, and it makes sense. But sometimes, depending on how nice your graph is, sometimes it's not always the best, okay? And it actually was supposed to be nice, but I changed the problem because I wanted to make it a little bit, I wanted to make it fit on my graph instead of that one. So let's look at this. Again, if we just kind of had to guess a little bit, let's guess that it is, let's guess that this is the point 2.25 and then 3.5. I don't know, something like that. And then we could check our answer by plugging this in. We'd plug it into both equations, the first equation and the second equation. So we'd plug it into the first equation is 2 times 2.25 plus the y value, which is 3.5. Is that equal to positive 8? Wait, it might actually be it. I didn't think it would be, but let's see. Well, that's going to be 4.5 plus 3.5. That actually is on the first line. 4.5 plus 3.5 is 8. That's great. I did not expect that. Let's see if it's a solution. Oh, it's not going to be a solution to the other one. All right, so the second one is x minus y equals -1. So x, we said that was 2.25. Minus y, we said that was 3.5. Is that equal to -1? No, it's close. We're going to get -1.25 when we type this in. -1.25. Is that equal to -1? It's close. Nah, it's not a solution. So the point is, you can solve things graphically. Let's plot this on Desmos. 2x plus y equals positive 8. Should look similar to what we graphed. And the other one was x minus y equals -1. And you can find, it was 2.25 and 3.25. So we were close in our guess, but it was actually thirds instead. So again, that's one of the nice things about graphing is you can really see visually what's going on. But sometimes if the solutions aren't really pretty, it can be a little harder. So the actual answer is 2.25, 3.25. Okay. Our guess was close. So now I want you to try it with potentially a nicer example. So, oh dear, graph it on this graph that I've totally included. I will include this on your graph. Making a quick note to myself. All right, great. So you'll have a graph here. And I'll just graph it on the same one I have right here. Okay, so we're going to graph this new equation. Pause the video. Try it now. Try to graph this and see if you can get to the solution. Okay, graph it by hand. Oh, wait, no, it says graph on Desmos. No, I didn't mess anything up. Graph it on Desmos and find the solution. Or graph it by hand if you want practice graphing by hand. Pause the video, see if you can get the solution. 2x minus 5y is -25. Great. And -4x plus 5y equals 35. My computer is doing some interesting things today. So again, you can go over here, find the intersection point. 1.667, that's 1 2/3. Right? And if you're ever curious, I think you can do this. Like if you do something like this, it'll... All right, you can check, right? There are a few ways of doing this, but I guess that's not fine. Or that won't work. But yeah, it's 1 2/3, -5 2/3. Those are repeating sixes. Or you can write it as a decimal. All right, 1 2/3, -5 2/3 is our answer. 1 2/3. Y is -5 2/3. Oops, that's not how you write that. Or you could say 1.6 repeating, -5.6 repeating. Or you could write your number as an improper fraction. And we could check our answers too. If we plug in these x's and these y's, both equations should be true. Let me know if you have any questions, and we'll get substituting in the next video.